Assalamu alaikum, Cam Theory. So we're going to look at some more branched alkanes, of course. We're going to reuse the rules that we listed in class, which is identify the parent chain first, circle/identify the branch. I put ES because there could be more than one. And remember that the branches always end in IL or YL. Identify the carbon number where the branch occurs, and name the alkane. And one thing that I want to remind everybody here is that for when we identify the carbon number where the branch occurs, we always, I'm going to write this here, always begin counting from side closest, right, to the first branch. Because in organic chemistry, we can count from either the left or the right sides. So here's the first molecule, or second molecule that we're going to do. And of course, I put the H's in the condensed form instead of just drawing all the bonds, because it takes a while. But each number of H's is dependent on, the number of H's per carbon is dependent on how many bonds a carbon will make. Remember that each carbon, if it's unbonded with another carbon, it's going to try and make 4 bonds with H's because it has 4 vacant spaces in terms of electrons. So here, the first thing is we're going to identify the parent chain. Now remember, like we said in class, the parent chain is the longest continuous carbon chain without double counting. Which, when we recount this one, this would be the longest carbon chain, because even though it goes, kind of like a sideways L, as long as we're not double counting any carbons, we're fine. And so when we number this is 1, 2, 3, 4, 5. And you could count it this way, or you could also count it like this. And it's 1, 2, 3, 4, 5. And both of them are correct. For simplicity, we're just going to use one of them, which we'll use this one here. And we said that anything that sticks out is the branch. So here's the branch. And then this over here is, of course, the parent chain. Now, the rule is that we're going to name the branches next. And when we name the branches, we count the number of carbons like we do our parent chain. But we're going to add YL at the end. So this has 1 carbon, so we know that this is a methyl. And so when we go to check our steps off, we've identified the parent chain. We've circled all the branches and we've named it over here. So we can check that. And then the next step that we're going to do is identify the carbon number that the branch occurs. Now, the first branch occurs over here. What that means is we could count from either this side and go this way, or we can count this way. However, we decide on which one is best based on which side is closest to the first branch, which in this case is the methyl. And when we look at that, this side over here is significantly closer than this side. So we're going to start counting from here. And counting them, we'd have 1, 2, 3, 4, 5. And so we see that it's a 3-methyl. Or sorry, not a 3. Whoops. Let's erase that part here. It actually occurs at the 2. If we look here, oops. The branch bonds over here. So this is going to be a 2-methyl. And then finally, with all this into play, so we can check this part off, we identify which branch the carbon occurs at, the methyl here occurs at 2. So your branch is 2-methyl. And then we're going to name the entire alkane, which is branch first, parent chain last, and we're going to keep the entire name, including the carbon number that the branch occurs at. And so finally, and I'll do this in a different color here, we'll make this a bit bigger. The final name for step 4 is going to be 2-methyl. And then if this is the parent chain, the one outlined in red, and it has 1, 2, 3, 4, 5 carbons, then it'll be 2-methyl pentane. And that is the final answer over here. So it is possible for us to have more than one branch on a single parent chain when it comes to the alkanes. Alkenes are alkynes, any one of them. And if there is more than one branch, we're going to use Latin prefixes, okay, ahead of the meth, eth, prop prefixes. So the Latin prefixes refer to the mono, di, tri, tetra, penta, hexa, hepta, and octa. And again, if there's more than one type of alkyl branch, or I would say just branch, then you get to place it alphabetical order. And we'll show you what that means with the following example. So for this one, we're going to do the usual, which is we're going to identify the parent chain. And that would be the longest continuous carbon chain. It doesn't have to be perfectly straight, but what you can't do is double count. And when we do that, we see that this over here is the longest continuous branch. So this is the parent chain. And then anything that sticks out, namely these two, are the branches. Right? Now, what we're going to do is name the branches. And each one of these are the same. They're both methyls, but there's 2 of them. So we're going to go back up to the Latin prefixes and indicate that there are 2 methyls. And we're also going to indicate which carbons these occur at. Now, if you remember, we start counting from the side that is closest to the first branch. In organic chemistry, we could count from this way or this way. But we'll count from here since it's closer to the first branch. And that'll be 1, 2, 3, 4, 5, 6. And so we end up with 2, 3 dimethyl. Okay, so 2, 3 dimethyl. We've numbered where the carbons occur at, or where the branches occur at. We put the Latin prefix because the methyl shows up more than once. And then we add YL for the branches. And then now we're going to name the parent. And if there are 6 carbons in the parent chain, then the full name, and we'll do this in black over here, is going to be 2, 3 dimethyl hexane. So 2, 3 dimethyl hexane. Let's look at a bit more of a complicated example. Now remember, it doesn't have to be a straight chain, the parent chain. It just has to be the longest continuous chain. And if we assess the longest continuous chain, here would be the longest because we would count every single one of these 1, 2, 3, 4, 5, 6, 7, 8 without going over a carbon twice. So this here is the parent chain. And then we have, again, more than one branch that shows up. These 2 are the same, and they're both methyl. So we would call this dimethyl. Now we need to also state where they occur at. We could count from this side, or we can count from this side. We're going to choose the side that is closest to the first branch, which in our case is this carbon over here. So when doing that, it's 1, 2, 3, 4, 5, 6, 7, and then 8. So these two occur at 2,3-dimethyl. This one over here has 2 carbons. And so when we go back to our prefixes for the organic chemistry compounds, this would be in eth. And it's ethyl because it is a branch, and it occurs at the 4th carbon. So we got 2,3-dimethyl, 4-ethyl. And so when we put this whole name together, if you look back at the rules, we use the Latin prefixes, and if there's more than one type of branch, we're going to place in alphabetical order. And so in this case, we ignore the prefixes, we just look at the branch name, and methyl comes after ethyl. So we're going to go 4-ethyl, 2, 3, and there's always dashes between the numbers, 2,3-dimethyl, and then the parent chain, if there's 8, it's octane. And I'll just rewrite the dimethyl here a little bit clearer. So 4-ethyl, 2,3-dimethyl, octane. And that's the final name of this compound. For this example, I want you to pause the video and try it yourself, then unpause it for the answer.